Hello, ladies and gentlemen. Today we're going to continue with our proofs. We are working on day 2, so we're just going to look a little bit deeper into these proof ideas and concepts. We're still going to be working in that proof packet that I gave you in class, so make sure that as we go through these, you jot down any questions or confusing points that you think you would like to be revisited. All right, so example 9 then. Given that angle B is congruent to angle C and angle D is congruent to angle F and M is the midpoint of DF, we are trying to prove that the two triangles are congruent. Again, since I have a picture here, we can go straight away and just start marking up our triangle. So let's start by marking what we're given. So we're given that angle B is congruent to angle C. We're also given that angle D is congruent to angle F. And lastly, we're given, oops, I better put 2 arcs on these angles. And lastly, we're given that M is the midpoint of DF. Now again, I can't directly mark this up, but I can deduce some information from that. The information I can deduce from that is knowing the definition of midpoint. Midpoint means that M is in the middle of the line DF. So that's saying that it is cutting DF directly in half. So when it's cutting in half, that means I'm making DM congruent to FM. So when I make those two congruent, I just draw on those markings, and now I want to look, okay, do I have 3 things, and can I use one of my postulates to make these triangles congruent, to prove that these triangles are congruent? So if you look here, I have made 3 markings, and I've made AAS. So then I think AAS, is that one of the postulates that proves triangles congruent? It is. So now that it is, I can go ahead and I can start my proof. When I start my proof, then again, we always want to start with our pieces of information that are given to us. So the first line in my proof should be angle B congruent to angle C. And again, that justification is given. So when we're writing these down, these first couple steps, again, should be the easiest part of our proof because this information is given to us. And since they gave us 3 things, I should be writing down 3 different given statements. So they give us that D is congruent to F, and we also were given that M is the midpoint of DF. So then when I look again, since I'm using AAS, when I go back to my proof, I better make sure that I have 2 sets of angles and 1 side. So already, just based on my given information, I've shown that there's a set of angles and there's a set of angles. So I've already shown both the A's, and even though I've marked it in my picture that these sides are congruent, I haven't yet written it in my proof. So the next thing I should do is to write that those 2 sides are congruent in my proof, so that way I can prove these triangles congruent. Now when I look at those 2 sides, again, we showed that DM is congruent to FM. And again, we were able to deduce that from this information that M is the midpoint. So since M is the midpoint, the reason we have to give that those 2 sides are congruent is by definition of midpoint. So by knowing the definition, that helped me to figure that those 2 sides are congruent. So now that I've drawn that in, I'm giving my side there, it looks like I have included all the information I need up to this point to prove these triangles congruent by AAS. So my final step would be to say triangle BDM is congruent to triangle CFM. And again, my reason would be AAS. So again, if you have any questions, make sure you jot that down. And don't forget to put our box in the corner to show that our proof is complete. All right, so jumping into example 10 then, our second example of today's lesson, we are supposed to prove that 2 triangles are congruent again, given the information that the segment WZ bisects angle XZY and angle WXY. So again, there's nothing I can mark right off the bat, but I can deduce some information from what it means to bisect. So again, bisect means to cut in half. So it's telling us that this segment WZ is bisecting 2 of these. Now notice the notation. We're bisecting 2 angles. So I should create smaller angles. So when I look at this and I look at WZ, the first one it says XZY. This segment here is bisecting XZY. So when I know that, again, it's cutting it directly in half. So I could say that this angle is congruent to this angle. Same thing on the other side then when I look at XWY, again it's getting bisected, so I know that these 2 angles have to be the same since ZW is bisecting that angle. So I've made the markings by deducing that piece of information strictly from what was given to me, and now I need to see if I can prove these triangles congruent. So far, I only have two things that are congruent to each other. I have two angles, but is there any other information I can deduce or infer from this picture? Actually, I know that ZW is congruent to ZW because that line is shared by both triangles. So when I throw in that third marking, it looks like these two triangles are going to be congruent using the ASA similarity postulate. So now I can get into proving what I am asked to prove. So the first thing, again, in all of my proofs need to be that I show and I write down that given information. So here I'm writing down just what I was given, and from there then I have to fill things in. So right off the bat with my given information, again, I'm not showing that any of these angles are congruent or any of my sides are congruent, so I have to go to work and write that in my proof. So my second step then, the first marking I made was to show that XZW was congruent to YZW. So that's what I'm going to write. Angle XZW is congruent to angle YZW. And the reason I knew this is because that I knew that ZW was bisecting that angle. So I knew that those angles were congruent by definition of bisect. Okay, so that is one of my angles. I can cross one of my angles off. The second marking I made then, so step 3 would be the other set of angles I was able to determine were congruent. So angle XWZ is congruent to angle YWZ. And again, we were able to determine those were congruent again because of the definition of bisect. We were told that ZW was bisecting that angle, so we were able to determine those two angles were congruent. So again, there's another A. So lastly, I have to show the sides, and we were able to show those sides were congruent because they were shared. So ZW is congruent to ZW, again, because it's the same line. But what's the property called when I am comparing something to itself? This would be the reflexive property. Okay, and so there's the S. Now that I've shown all of those steps in my proof, I can go ahead and show that these angles are congruent. So triangle WZX is congruent to triangle WZY. And again, my reason for this is ASA. Finally, let's draw that box, and this proof would be complete. All right, our last example for today is going to be example 11 in your packet. Okay, again, we're going to start by marking what's given to us. So in this example, we're given that AB is congruent to BD, so I'm going to mark those with 1 hash, and BC is congruent to BE, so I'm going to mark those with 2 hashes. So again, I need one more piece of information because anytime I'm trying to prove triangle is congruent, I need at least 3 markings, and right now I only have 2. So the other piece of information I can do is by just looking at these triangles is it looks like we're going to have a set of vertical angles. So when I mark those congruent, it looks like I can prove these triangles congruent using SAS. So when I go over and I start my proof, I have to make sure I include all 3 of those things. It's nice in this example because we're given 2 pieces of information right off the bat. AB is congruent to BD and BC is congruent to BE. So now when I look at composing the rest of my proof, I just have to make sure that I include 2 sets of sides and 1 set of angles. So it looks like the first thing I was given is a side and the second thing I was given was another side. So that leaves me only to prove or to show that I have 2 congruent angles. And we've shown that in the middle by using vertical angles. So we got to get that written in our proof. So my third step here, I can't just say that angle B is congruent to angle B strictly for the fact that angle B is touching 4 separate angles. So when I list these, I have to be more specific. So by being more specific, I could use 3 letters, ABE, congruent to angle DBC. And again, I have to have the A and the B in the same position because those would be my congruent angles. So the reason for that would be our vertical angles theorem because those are the angles that are right across from each other. So vertical angles. Okay, so now that I've included that, I have an S, an S, and an A, so I can prove these triangles, and I'm done proving these triangles congruent by SAS. So that leaves my final step to be triangle ABE would be congruent to triangle DBC. And my reason for that would be SAS. Again, conclude your proof by using the square. All right, so those are the 3 examples that I'm going to go through with you today. So your job then as homework is to complete numbers 12 through 15 in your packet. Again, if you have any questions as you're working through these, just make sure you jot them down and we can discuss them in class. So I want to thank you for taking good notes, and I'll see you when I see you.